Good day, students. Let's go ahead and take a look at question number 1. It says the graph of y equals x squared is shown on the grid. Drag the graph to show y equals x minus 4 quantity squared plus 2. All right, so this is basically assessing your ability to transform quadratics. You know that the vertex form of a quadratic is given by y equals ax minus h squared plus k. Alright, so all we need to do is find the vertex. And then the vertex will tell us the shifts. There aren't any dilations or reflections here because a is equal to positive 1. Alright, the vertex is basically, for the vertex form is h comma k. Okay, so in this problem we have y equals x minus 4 quantity squared plus 2. If we find the vertex, that will tell us what the shifts are. In this case, our shifts are h units to the right and k units up. If this was negative, it would be h units to the left, and if this were negative, it would be k units down. All right? So let's find the vertex of this situation that's given to us here. So it's going to be illustrated by this function right here. So the vertex, what you do is you take the opposite of the number next to the x, which is going to be positive 4, and then the other number that has been added to this squared quantity, you just take it the way it is without inverting the sign, okay, because it's not next to y, it's on this other side of the equation. So you take the opposite of the number next to x and then just drop down the other number, okay? So this gives you your vertex. Now, what are the shifts? What did this coordinate tell us about the shifts of the y equals x squared graph? Well, it tells us since this is positive 4, your shifts are going to be 4 units to the right, and since this is positive 2, 2 units up. Remember, this is your x-axis, which goes side to side, and this is your y-axis, which goes up and down. Okay, so just follow the direction. So 4 units to the right and 2 units up will take us to the vertex of the quadratic. All right, so how do we do that here? Let me show you how to do that here. All right, so what we're gonna do is it says drag the graph to show. Okay, so all I'll just do is drag this. So you have to be really careful to make sure that your vertex aligns with 4 and 2. Okay, so we're gonna go 4 units to the right and then 2 units up right there. Okay, so this is a drag and drop type situation, and there goes your answer. All right. Okay, so click next to go to the other one. All right, this one's already in the right. Plus 2 comma 4. All right, and then you just click next to go to the next question. All right, if you want to, for the first section, section 1 through 5, you can go back and forth, otherwise you can't. Okay, so this one I can go back just to make sure my answer is correct. All right, let's take a look at question 2. Question 2 says, consider the function f of x equals x squared minus 5x minus 14. Which of the numbers in the chart are zeros of the function? Select yes or no for each row. So by clicking on each row, you can select yes or no. Okay, so at the end of the day, we're going to have a check mark in each row, either yes or a no. Okay, all right, so it's asking for zeros. How do we find zeros of a function? Well, there are 2 ways we can do that. I'm going to show you the first method, which is much more effective. Method 1 for finding zeros of a quadratic equation is by factoring. Okay, factoring. All right, so let's do it by factoring. So if I want to find the zeros, what I'll do is I want to solve this equation, x squared minus 5x minus 14 equals 0. Whatever satisfies this equation will give me the zeros of this quadratic function. All right. So how do we solve this? The method I wanted us to use is factoring. Okay. So we're going to use the AC method. So I'm going to make my little x here. The factor AC goes on top, negative 14, and B goes on the bottom, negative 5. All right. So what 2 numbers multiply to give you the top and add to give you the bottom? We can use 7 and 2 Since the difference is negative, the bigger number will be negative. All right? So we're going to put this into this equation. It will have x squared minus 5x, actually minus 7x, x squared minus 7x plus 2x minus 14 equals 0. All right? So partition it down the center and factor by grouping. From the first two, I'll take out an x. I'll be left with x minus 7. And then bring down the sign positive, take out a 2 from the last two, be left with x minus 7 equals 0. Okay? Now, to factor by grouping, you're going to have x plus 2 times x minus 7 equals 0. All right? Next, we're going to set each factor to 0. X plus 2 equals 0, and x minus 7 equals 0. And we're going to solve this. Okay, this one yields x equals negative 2, and this yields x equals 7. So these are the zeros to this quadratic function. Now, where do we see negative 2 here? We have negative 2, and then we also have positive 7. All right, so for positive 2, we have a no, and then you have for negative 7, you have a no. So all you do is you just hover your mouse around the cell you want to check. You want to click, have a check mark on, and you just click on it, and then you have a check mark there. Okay, so that's basically how you answer a question like this. All right, so which other method can we use to solve this? We can also use the plug and chug method, or just the substituting method. Okay, so method 2 is by substitution. Method 2 is by substitution. In this case, you do not necessarily need to know how to factor, but you have to be excellent in your order of operations, again, arithmetic skills. So for the substitution method, all you do is you plug in all these 4 candidates and see which one yields an output of 0. All right, whichever one yields an output of 0, that's going to be considered a 0 of the function. All right, so we're going to start with x equals 2. So for x equals 2, we're going to compute f of 2, which is equal to positive 2 squared minus 5 times 2 minus 14. All right, how did I come up with that? We know the original function was x squared minus 5x minus 14. So what I'm doing is I'm taking my candidates here and I'm plugging them into the original function. All right, so let's simplify this. Order of operations, exponents and products first. 2 squared is 4 minus 10 minus 14. This gives us 4 minus 24, which is equal to negative 20. Is this a 0? Absolutely not, so we know that the first option is no good. All right, next candidate is x equals 7. This is one of the answers we got in method 1, so it should work here. We're going to compute f of 7. What does that mean? It means that you're going to plug in 7 for all your x's. So we're going to have 7 squared minus 5 times 7 minus 14. If I work this out, 7 squared is 49. 5 times 7 is 35 minus 14. That yields 49 minus 49, which equals 0. That's excellent. All right, so 7 is one of the zeros. Now let's try the next method, which is x equals negative 2. So what are we going to do with that? We're going to evaluate f of negative 2, which is the output you get when you input negative 2 into the x's of your function. All right, so we're going to have negative 2 squared minus 5 times negative 2 minus 14. All right, if we work this out, negative 2 squared, you have to know that when you square negative, it becomes positive 4. And also minus times minus is plus 10 minus 14. So you see, using this substitution method, you have to be really careful in your arithmetic and order of operations. A lot of room for mistake here. Okay? If you work this out, you're going to have 14 minus 14, which equals 0. So that also qualifies as a 0. Last but not the least is x equals negative 7. You see how arduous this process is? You actually have to check all the options in order to arrive at a solid conclusion. Had it been you factored like in method 1, you only get the answers and you know the other ones are inaccurate. Okay, so for this one, we're going to evaluate the function at the value of -7. So what we have is -7 squared minus 5 times -7 minus 14. If you work this out, you're going to have 49 plus 49 plus 35 minus 14. All right, and that gives us 84 minus 14, which equals 70. This clearly isn't 0, so -7 is not a 0 of the function. Alright, so you can clearly see that 7 and 2 are, and -2 are our answers. Alright, let's take a look at question 3. This is another drag and drop question. It says drag the correct number to the exponent of x to write the expression as a single term. So let me just show you something real quick. You can drag any of these and put in the box right there, okay? And if you don't want it, and then maybe you want to change your answer, or there was an accident, you just click delete, and then you click on the object you want to remove, okay? So let's try this one. Let's say it was 2/3, that was the answer. And I want to change that. I'll click on delete. See the instructions here, it says select an object to remove. So you just select the object that you inserted into your solution space, and that will get deleted. Okay, so that's how you correct your work. All right, let's go ahead and solve this. This is assessing our ability to use the properties of exponents. So we have, for number 3, we have the third root of x times x to the 3/2 times x to the -5/6 over the square root of x. All right, how about we use the fractional exponents property to express everything as fractional exponents. All right, so we're going to express this one as this. We're going to be using the nth root property here to express these two. This would be the special case of the nth root property, and then this would be the nth root property. So the cube root can be written as x to the 1/3 times x to the 3/2 times x to the -5/6 divided by, using the special case of the nth root property of exponents, square root of x can be written as x to the 1/2. Alright? Now using the product property of exponents, it tells us that when we're multiplying exponents of the same base, you add the powers. And when you're dividing, you subtract. Alright? So this is going to be written as x to the 1/3 plus, for this multiplication here, 3/2 plus, for this multiplication here, -5/6 minus, because this has been divided by, 1/2. Alright, so now we're just going to focus our attention on the numerator, and then we have to just resolve this fractions by combining them. Alright, so now it's arithmetic, no more algebra here. If you want to add fractions, what you have to do is you want to multiply, you want to make all the denominators the same, okay? Alright, so the LCD of, well, let's look at the denominators. The denominators are 3, 2, 6, and 2. The LCD of 3, 2, 6, and 2 is 6. So we want all the denominators to be 6, so this one will multiply by 3 top and bottom. This one will multiply by 3 top and bottom. And then this will multiply by 2 top and bottom. Okay? Alright, so what does that give us? We're going to have x, let's change the color of this. So we have x to the, sorry, the color keeps changing. So make sure I have the right one right now. Alright, so if we do it, we're going to have x to the, so we're just going to be multiplying the powers. Sorry about this, I'm having some difficulty here. So let's just use red. So we have x to the 2/6 plus 9/6. And then this plus times this minus will become a minus, minus 5/6. And then the last one will be minus 3/6. Okay? So those are the numbers that we're going to be working with here. Alright, now let's go ahead and, since we now have all the powers are now the same, we're going to go ahead and just simply add up the fraction, okay? So we're going to have x, we're going to have 2 plus 9 minus 5 minus 3, the entire thing divided by 6. Okay, that's for the power. So now we're going to have, let's simplify that, we'll have x, 2 plus 9 is 11, and then we have 11 minus 5 minus 3 is minus 8 over 6. So that gives us x to the 11 minus 8 is 3 over 6. And when you reduce that, you have x to the 1/2. Okay, so that's the power that we're going to have when we simplify this expression. All right, so all we do is we're going to drag 1/2 and then put it right here, and that will be our final result. All right, let's take a look at question number 4. So for question 4, we have a polynomial function that's graphed here, and we are asked to create a possible function for the graph. All right. So what we're going to be looking at here are the zeros. Okay, we're going to use the zeros to generate the function for the graph. So what are the zeros? The zeros are the points where the graph intersects the x-axis. Okay, so we're going to have the zeros are our x equals, the first one is -3, is between -2 and -4, -3. We also have -1. We have -2. And lastly, we have, actually it's +2. +2 is a double root, so we have +2. Fix that. So +2. Let's put it twice, x equals 2, and then x equals 2. And then lastly, we have x equals +4. All right? So in order to use the reverse of the zero product property, we need to set all these equations equal to 0. So to set this one to 0, we need to add 3 to both sides. So you have to add 3, add 3. So the first equation, we have x plus 3 equals 0. For this one, we have to add 1 to both sides to make it equal to 0. And then we have x plus 1 equals 0. And then for this one, you minus 2 from both sides to make it equal to 0. X minus 2 equals 0. Same story for this one. X minus 2 equals 0. And then for the last one, x, you subtract 4 from both sides to make it equal to 0. X minus 4 equals 0. Alright, so now what we're going to do is we're going to multiply everything, all these quantities, and set them equal to 0. Okay, so we're going to have x plus 3 times x plus 1 times x minus 2 times x minus 2 times x minus 4 equals 0. Okay, so this is a drag and drop question again. So we're just going to pick up the factors in this order. The order doesn't really matter since multiplication commutes, but let's just keep our work consistent with our solution, okay? So the first one, starting from the smallest, was x plus 3. So you just drag and drop x plus 3, and then x plus 1, drag and drop. And then you have x minus 2, drag and drop. You have another x minus 2. The reason why we have 2x minus 2's is because you have a vertex right here. That's known as a double root. Okay? Unlike the other points, it's just, you don't have a vertex. It's just a clear intersection. Here you have a vertex, so you have a double root there. That's why we have 2x minus 2's. Okay? So anytime a vertex falls on, anytime a vertex is a 0, you always have to count it as 2. Okay? So keep that in mind. And then x minus 4, you just have one root there. Like that. And there goes your answer. Okay? All right, let's take a look at the next one, problem number 5. All right, this is a kind of problem where you can actually figure it out without even doing any work at all. So it says, look at the graph and the algebraic statement. Place the correct mathematical symbol in the box so that the number line displays the solution to the algebraic statement. Okay, so first of all, this is a closed circle. So that indicates inclusion. All right, so we have the 4 inequalities: less than or equal, equal, greater than or equal, and greater than. Since it's a closed circle, this and this are automatically eliminated. If it were an open circle, then these 3 will be eliminated, okay? So this is a closed circle that's eliminated. Now, since this is a region and not a point, this is also eliminated. Okay? Less than is like open circle going to the left. Greater than is open circle going to the right. Equal is just closed circle. Alright? Less than or equal to is a closed circle pointing to the right, to the left, sorry. And then greater than or equal to is a closed circle going to the right. Now, you do not want to be in a haste to pick one of these answers. You have to look at the equation because there could be reflections, all right? So if you look at this problem, you notice there's a negative in front of this x. So what does that mean? It means that whatever the initial inequality is, when you're solving it, there's going to be a reflection. So this is less than, but because of this minus, we need to use the opposite. So the correct answer will be, this is greater, sorry. So we're going to use the opposite, which is less. So this would be the correct answer right here. How do we know that will be the correct answer? Because this minus will cause this less than to switch to the other direction to be a greater than. All right. So just based on this orientation, we can see that the answer is option, the second option right here. So you just drag it and drop it. Okay. So that's how you can do it by inspection. Let's actually do the whole problem. Let's solve it so that you can see that our guess was actually correct. All right, so let's actually solve the problem. So we have negative 2 times x plus 3 is less than or equal to negative 10. We can divide both sides by negative 2. So divide by negative 2 and divide by negative 2. Now, anytime you divide by negative, what happens to your inequality? It's reflected, it switches, right? So it was less than or equal before. Now it's going to be x plus 3 is greater than or equal to positive 5. That's why I was telling you that when you're selecting the inequality, you have to select one that's opposite because the minus will actually cause a reflection to happen. Alright, so to finish this off, you subtract 2 from both sides. Subtract 3 from both sides. And then you are going to have x is greater than or equal to positive 2. Okay, greater than or equal to positive 2. And that's an inequality where you have 0, positive 2, you have a closed circle on positive 2, and greater than means you're heading to the right on the number line in the direction of increment. Okay, and that's exactly what we have here. So the correct symbol is less than or equal to, because when we put in less than or equal to in our equation, it gave us the correct resulting graph. Had we use this one, it will be having pointing the other direction, okay? And if we use this one, it would have been an open circle pointing to the right, and this would have been an open circle pointing to the left. And if I'd use this one, it would just be a point, okay? So let me show you the different cases. So this one right here, this one we just did is less than or equal to. Had we done greater than or equal to, would have had this solution. It would have looked like this. Positive 2 with a closed circle pointing to the right. Okay? And then for this problem, if we had done equal to, it would just be right on positive 2. If we solved it, we would have had this would be our answer. And then if it were less than alone, this would be an open circle. If it's very greater than alone, it will be an open circle going in that direction. All right, so we can clearly see that this is the answer because after solving it, we end up with this situation right here. All right, so that's that. So thanks so much for taking the time to watch this tutorial. Feel free to subscribe to my channel by clicking here so you can get updates to other parts of this tutorial on how to take the exam. Please post a comment to let me know what you think, and do click like if you liked it. Feel free to share it with your friends, and more clips can be found on mygloveserve.com. Thanks again for watching, and have a wonderful day.